Boom. Alright. So, I remember talking with you the other day, and you were like, oh, all those people are so lucky they got to see your presentation. And I haven't even gotten a chance to see your presentation, so I was like, well, needless to say, I was fairly sad about that. So, I kind of wanted to reverse your luck. So, I figured I do my oral PowerPoint presentation for you, and it's kind of on a little bit on a time crunch because it's like 12:31 right now, and I have to be in Cudahy by 1. But I figure I can spare like 15 minutes or so, just for you, baby, just for you, just for you. Okay, baby. All right. Well, this is how it's gonna work. I'm gonna have this little clicker thing for my laptop. That's how I'm gonna transition between slides. I'll send you the PowerPoint via email, and maybe you can open it up, follow along. So every time that I click, you can transition the slides for yourself. You should be able to follow it. Okay. I'll also be timing myself, so I'm just get everything in order. By the way, how you doing? Oh. Okay. You ready, babe? Have your PowerPoint set up? Got the screen open? Okay, looking good, okay. I press set, and I press start, 15 minutes and counting. Alright, here we go. Hi, my name is Tommy Day. I'm a senior at Marquette University under the major of biomedical science, specifically in the College of Health Science. My research this summer is under Dr. William Colin and Dr. Dana R. Ziegler. If I can figure out how this works, it would be cool. Oops, not what I want. Okay, you know what? We're gonna start that over again. Alright, let me see if I can figure out all these little thingamabobs. Go back, bitch. Okay, USA. Okay, alright, we're gonna try this again. Ready? And start. Hi, my name is Tommy Day. I'm a senior at Marquette University under the College of Health Sciences, specifically with a major of biomedical science. I am researching this summer about gap distribution in the brainstem region. My mentor for the summer is Dr. William Coleman, Professor and Dean of the College of Health Science. Also assisting him is Dr. Dana R. Ziegler, Associate Research Professor. What is stress? There are two types of stress, psychological stress and physiological stress. Examples of psychological stress are novel environment and isolation. And examples of physiological stress also include. My research is more involved with the physiological aspects of stress, and examples of physiological adaptations are the secretion of glucocorticoids, such as cortisol. Glucocorticoid has numerous effects in your body, and here's a list of just a couple of examples. For one, homeostatic regulation of metabolic processes, reducing immune function, and also it's necessary for survival. We know that animals who lack a glucocorticoid feedback system can't survive in a stressful and enduring environment. But a definition of stress and a mentioning of it would be incomplete without a reference to the HPA axis. HPA stands for the hypothalamic pituitary adrenal axis. And basically this is the cascade of steps that the hormone needs to go through in order to secrete cortisol. It all begins in the hypothalamus with the release of corticotropin hormone, which is CRH, then travels its way to the anterior pituitary with the release of ACTH, which that enters the circulatory system and makes its way to the adrenal glands right above the kidneys, and that, in essence, is how cortisol is released. Particularly, even in the structure of the hypothalamus, there's even a more exact structure called the PBN, which stands for the periventricular hypothalamic nucleus. This PBN is known to be the common converging point of all brain regions that communicate to the HPA stress response. And the PBN is labeled in this red box that I highlighted. So you can see that it's a very small structure within the hypothalamus and with a very exact structure. So the holy grail of current research worldwide is to construct a comprehensive neurocircuitry map of all brain regions and neurotransmitters that project to the PBN. So basically, the picture right below that is a sagittal section of the brain. So in the end, we're hoping to map out all the neurocircuitry involved of the brain. So we'll maybe come up with a picture similar to the one that I'll show you now. This table lists regions of previous exploration. This data table spans from 1981 to about 1998. So it's not the most updated table, but it's definitely one of the tables that kind of gives you an idea of the extensive research that's already been done on exploring brain regions. Now, at Marquette University, under my mentors, we're focused on the inhibitory effects of GABAergic neurons on the PBN from all brain regions. Specifically, we're using glutamic acid decarboxylase as our marker, which is pronounced GAD for short. Well, the reason why we use GAD as our marker for GABA inhibitory neurons is that GAD is an enzyme that assists in GABA formation. So if you have GAD presence in one area, then that's a pretty good indication that there's going to be also GABAergic neurons in that area also, because GAD is a precursor to GABA. And the general focus of the areas that we're trying to map is in the forebrain region and in the brainstem region. Now, the general brain regions that project to the PBN are listed in this table. They're in the kind of like the dark boxes. It begins with the limbic system, which is kind of in the forebrain region, and goes to the CV, which is the circuloventricular organs, and the hypothalamus is the local circuitry that are involved with the PBN. And the brainstem is kind of like the area that hasn't been explored too well yet, and it's well, as I'll mention later. It's part of my summer research. I want to expand the GAD map into the brainstem region because previously the forebrain region, the hypothalamus, and the circuloventricular organs, they've already kind of been experimented on and they've already been mapped. So I want to expand my research into the brainstem region and complete that neurocircuitry map of all GABAergic neurons. And I used two experimental procedures to come to my conclusion. One is called in situ hybridization and immunohistochemistry. And before I move on to that, I'd like to give some recognition to my test model, which is the adult male frog dolly rat. We decided to use the male adult ones just to keep the data consistent as compared to other sex